So we stop here on Tuesday, and we want to discuss this example. And example, we want to discuss this topic that we discussed that in determining the determining the force vector, we need these three direction cosines. But in reality, in the reality, we usually do not know these direction cosines, and we only know the force goes between M and N, and we know the coordinates of M and N. We know the force goes from M to N, and we know the coordinates of M and N, but we do not know the direction cosines of the force. Is that okay? So how should we go? How should we move on from here? First of all, we write down the coordinates of M and N. Be careful that we can use brackets to mark coordinates, but when we write force as vectors, we must use I, J, and K. Is that clear? We must use I, J, and K to mark our vectors. For the next one, after we know what M and N are, we can write down the vector between points M and N. We can write down the vector between points M and N. So how should we write down? Because we know the coordinates of M and N. We can write Mn as a vector, like xn minus xm as I. Or sorry, we should write x2 minus x1. x2 minus x1i plus y2 minus y1j plus z2 minus z1k. Is that okay? Because we know the coordinates of M and coordinates of N, then the vector between M and N is this one. Is that okay? If we accept this, but this vector has magnitude and has direction. It has a magnitude and it has a direction, and we only want to know the direction of this vector. We don't need the magnitude because I don't care whether this is 1 meter, 2 meter, and we don't care. We only want to know the direction of this vector, right? We only want to know the direction of this vector because the force is in this direction. Therefore, we first determine the distance mn as a scalar. So it is, of course, you can do the mathematics. And we let this variable as d. we let this variable as d. So after we know the distance of mn, let's rewrite mn in another way. Let's rewrite mn in another way. Let's copy it and you can see whether it is okay to do this. Is it okay for me to do this? Let's you can first you can write it down first and think about it. From this mn, we multiply d and we divide the terms by d. And we simply multiply the vector mn by d at the front, and we divide each term by d. Is that okay? It sounds logical, right? Now we use the same logic we used before. What's the magnitude of mn? As we have written here, the magnitude of mn is this one, is d, right? D. And this one, the magnitude of this one is d, of course, because it is a scalar. So what is the magnitude of this one? What's the magnitude of this vector? 1. Very good. So this one is a unit vector in the direction of mn. So for those of us in room 203 and online, are you okay with? Can you see the things on my screen? Raise your hand if you can, especially those online. Okay, good. Thank you. Is that okay? Write it down first and we come because for so we I'll come back in a minute. Let's go back to page 15 of the notes. That's the previous page. The unit vector in the direction of f has this form, has this layout: cosine theta xi plus cosine theta yj plus cosine theta zk. On the textbook is 2.21. In this example, we have we get this, we have this, and on the previous page, on page 50, on page 15, we had that. So we compare these two. So we get the following things. Remember, we have 3 direction cosines. If you answer these questions, you need to give 3 answers, 3 values to form one answer. This is 2.30 on page 58 of your book. If you don't want to copy this down, and at least you can, it is on page 58 of the yes, page 58, 2.30. If you are using an old book, that it is somewhere around there. Is that okay? And so if you can first write it down. And for those who have written copy everything down, that I have a question to. Any problem? Any questions? If you don't have questions to me, then I have a question to you. In this one is in Chinese, it is this, right? In Chinese, compare is this one. So after English verbs that we have, we always have the words like to, in, with, on, right? And these things, for, and these things. These are, what are these called? This one, or right? So, and if we want to compare these two, and we want to use one of these, which one should we use? Okay, somebody has said with. Are there any answers? 2. Good. So which of them is correct, or both of them are correct? I think you have seen both of them, right? So who said only this one is correct? Can you raise your hand? 1. Only 1. Okay. Only this one is correct. 1, 2, 3, 4, 4, 5, 6. How about the others? You think so? Both of them are correct. If you think both of them are correct, you can raise your hand. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And so the answer is both of them are correct, but they don't have the same meaning. Okay, they have different meanings. Let me write down. And my PhD professor taught me this, and I only knew that I did not know that when I was year one. I only knew that only when I was a PhD student. So let me write it down. If we say compare A with B, we are simply comparing them. We are saying the similarities and differences between A and B. If we say compare A to B, it means it's okay. You can ask your friends and whether they know this next time. So usually of course in science we use compare A with B, but now you know if somebody say compare A to B, it means something more. Is that okay? Now we come to the next page, and because we have only like 10 minutes left, and because I also want to do the closing remarks, and let me see which one I should do first. Okay, let's do sample problem 2.7. I will only do part of it, and because it is on the textbook, and you work on the rest of it. So we have a wire AB. We have a wire. We have a tower. A tower. This is a tower. Wire is this one. This one is this one. So we have a tower, this one, and then this wire is fixed at anchored or fixed at A. The tension in the wire is 2,500 Newton. So determine means we need to know, right? We need to know the components of Fx, Fy, and Fc of the force acting on the boat. And the second thing is the angles theta x, theta y, and theta z, defining the direction of the force. So in this question, this is quite special. We we want to determine the angles, but usually we want to know the direction cosines. Usually we want to know cosine theta x, cosine theta y, and cosine theta z, right? But in this question, that is quite special. It asks for we need to determine the angles theta x, theta y, and theta z. So let's work on it. In this problem, we will work on we know the y goes from A to B. Therefore, because we want to know the force acting on the boat. Because for this force, we can either determine this right or this. We can either determine the one on point B or this one on point A. It's okay because we have one wire and the tension in the wire is 2500 Newton. Therefore, we can either determine this or determine this. He said, can you see this? We can either work on this or work on this. But remember, the question asks us for the force acting on. Acting on is on the boat, on this one. So we should calculate this one, but not this one. It's okay. Therefore, AB is the force of the direction of force is in the direction of A to B. A to B. And the force is the direction from A to B is defined by this vector. And the distance AB is 94.3 meters equal to D. You can work it out. I think you can work it out. You can get it from your own using your calculator. From here, we can know that cosine. You can please. Of course, it is on the book, but do it once at home, and you will get cosine theta x is equal to 90. The direction cosines are these three. Oops, sorry. I would say this one is homework. Therefore, sorry. So for this part, please do it at home. and you should get these. This is the answer for part B. Of course, you can answer part B before part A if you, but please mark your answers with a box. So to determine the force components, let me give you an idea, and you can work at home. On the you can find it on notes page 14 or book on the book textbook is equation 2.20. All right, that I think it is written here for you, so so you don't need to copy this. So this one is this one. This one is I'm talking about this one. And because we know cosine theta x, cosine theta y, and cosine theta z, the force F, and we are given F equals to 2,500 newtons, right? So we can determine this three. Okay, thank you. We can determine these three force components. Is that okay? So let me stop recording and do the final remarks.